The researchers have discovered something that could be even louder and more significant than the Big Bang, which has astounded people who are interested in science. The information was shared that the shockwave has a size that is absolutely enormous. Should we be concerned about the shockwave that is about to hit us? Is the Milky Way the largest galaxy in the universe? How big is the Milky Way exactly? Let's dive in and know more. The universe around us is as mysterious as it is vast. We don't know much about it, but the things scientists have figured out are quite incomprehensible to the average person. With the advent of space science and the rapid technological development of this century, scientists have discovered many incredible and downright mind-blowing things in the universe. We are a tiny part of it. Researchers utilizing the MeerKAT radio telescope in South Africa have discovered evidence of a shockwave. After conducting additional research, it was determined that the shockwave is moving at a speed of 1,500 kilometers per second. According to the findings of the researchers, this shockwave was caused by a galaxy cluster known as Abell 3667, which consisted of a total of 550 other galaxies. In 1610, Galileo was the first person to resolve this band of light into distinct stars using his telescope. Interestingly, almost all astronomers believed that the Milky Way contained all of the stars in the universe, but the 1920 great debate between Harlow, Shapley, and William Herschel proved otherwise. And Heber Curtis's observations, along with Edwin Hubble's, led to the idea that the Milky Way is just one of many galaxies structurally. The Milky Way is a barred spiral galaxy with an estimated D25 isopropyl diameters of 26.8 plus minus 1.1 kiloparsec x. The spiral arms of the galaxy are, however, only 1,000 light-years thick. Recent simulations produced by scientists also suggested the presence of a dark matter area. Scientists believe that the Milky Way's constant rotational speed contradicts Keplerian dynamics, and they've concluded that much of the Milky Way's mess is invisible to telescopes because it doesn't emit or absorb electromagnetic radiation, and this mass is what we now call dark matter. As a whole, the Milky Way is moving at an incredible velocity of 600 kilometers per second with respect to the Sun. Scientists at the Hamburg Observatory in Germany, the shock waves function as massive particle accelerators that accelerate electrons to nearly the speed of light. The waves are threaded by an intricate pattern of bright filaments that trace the location of giant magnetic field lines and the areas where electrons are accelerated. The shockwave might be a recent discovery, but it certainly isn't new. In fact, it was first blasphemed in the year 2000. I also spent time studying Table 3667. If you look closely at this picture of the table, you'll notice the white color in the center, which is a concentration of 550 individual galaxies, but the red hues on either side represent shock waves formed during the formation of these superclusters. This discovery is considered a game-changer in the field of study focused on understanding the merger of galaxy clusters, but it's not the only astonishing discovery. They discovered a huge cloud of hot, faintly glowing gas in outer space that is much bigger than the Milky Way galaxy. This is a one-of-a-kind cosmic gas cloud. It's possible that it stripped away from a galaxy. The surprising revelation was that, instead of dissipating somehow, this cloud had managed to stay clumped together for hundreds of millions of years after analog. It was also revealed that the cloud was spotted in Abell 1367 or Leo cluster, which contains nearly 70 galaxies and is located about 300 million light-years from Earth. The scientists were eager to figure out how the gas didn't dissipate despite being stripped from its galaxy so long ago. Their calculations revealed that a magnetic field is capable of holding the gas cloud together against instabilities for a long time, so it's only logical to assume that. While the voids continue to grow, such discoveries and more helped scientists gain a window into what the universe looked like in its earliest moments. While the revelation of more and more secrets from space is terrifying because it only proves that we know very little about the endless universe around us, experts believe that no amount of fear should stand in the way of acquiring as much information about outer space as humanly possible. Abell 3667 is a galaxy cluster in chaos located approximately 730 million light-years from Earth. Abell 3667 is actually two clusters, or groups of galaxies colliding into one another, containing over 550 individual galaxies, slowly stirring into one big cosmic gumbo. Most telescopes can't see it, but this cosmic collusion has caused a massive disturbance in the region, a massive shockwave flaring out from either side of the merging cluster, visible only in radio wavelengths. A new study published in the journal Astronomy and Astrophysics provides the most detailed picture of this massive wave ever captured. The researchers imaged both halves of the shockwave's radio component, also known as radio relics, using the MeerKAT radio telescope array in South Africa, and discovered that the structures are far more complex than previous observations indicated. The shockwaves act as giant particle accelerators, accelerating electrons almost to the speed of light, said lead study author Francesco de Gasperin, a visiting scientist at Germany's Hamburg Observatory. The waves are threaded by an intricate pattern of bright filaments that trace the location of giant magnetic field lines and electron acceleration regions. The shockwave was created approximately 1 billion years ago when the two galaxy clusters that comprise Abell 3667 collided for the first time, according to the researchers. Galaxy clusters are the most massive gravitationally bound structures in the universe, and when two of them merge, they release the most energy in a single event since the Big Bang, according to researchers. As the wave propelled electrons into space at near light speed, the particles ripped through magnetic fields in the area, emitting the twin arcs of radio waves seen today. The radio arcs move at more than 3.3 million miles per second, are about 13 million light-years apart, and are 60 times larger than the entire Milky Way galaxy, which spans about 100,000 light-years in diameter. What factors contribute to the production of shockwaves? There is no way to count the number of galaxies that exist. The Milky Way is the only galaxy in which Earth can be found. It is so vast that it would take 1 million years and 1,000 million years, respectively, to travel through it. In a similar vein, there are also things that are known as galaxy clusters, which are essentially collections of different kinds of galaxies. When gravitation enters the picture, there is a good chance that two galaxy clusters will be drawn toward one another, which will result in a catastrophic collision and the appearance of fireworks in space. It is a common practice to rank these collisions among the most powerful events that can take place in our universe. This is the process by which shockwaves are produced. When two galaxy clusters collide, a pair of massive shockwaves move through the new cluster. This is similar to the expansion of sound waves from high-speed planes. When two massive galaxy clusters collided more than 1 billion years ago, they formed Abell 3667. An international team of astronomers has conducted the most comprehensive study of these cosmic sound waves. According to the study's lead author, these structures are full of surprises and difficult to study. Sound waves contain massive atom enablers. They can move electric charges at nearly the speed of light. As a result, when these fast electrons pass through a magnetic field, they emit the radio waves we see in the sky. A complex pattern of bright filaments shows where huge magnetic field lines exist and where electric charges are enhanced. And that's it for today, guys. We sincerely hope you enjoyed the video. If so, please click on the like button and share it with your friends and family. If you have any questions or comments, please share them with us in the comment space below. Also, don't forget to subscribe to our YouTube channel to see even more of our incredible videos. You can also check out our other videos that have been specially selected for you. We'll catch up in the next video.